So evaluation matrix in the sense, once you develop a model, right? Once you develop a classification model, right? Especially we use these evaluation metrics for classifications, right? Classification in the sense whether you develop a machine learning model, right? I already told you in the initial stage we pre-process the data, then we are splitting the data into training and testing, right? So what is the percentage normally we are splitting? I told those things. Tell me.
18 to 20.
So 80-20, right? 80-20. Maybe that is normal ratio. Maybe we can change the ratio depending on the size of the data, some other parameters. We can change these, right? So once you are split training 80 percentage, testing 20 percentage, right? So once you complete the model training, right, you have another 20 percentage of the data, right? Why you are using that 20 percentage to test your model, right? Once you develop the model, you can test your model whether your model works correctly in the sense, once you develop a model, the purpose of that model, your model need to do some predictions. Your model need to do classification, whether it's cat or dog, whether yes or no, so whether positive or negative, those things, your model need to be predict, right? Depending on the data set you are training, your model need to predict the new data, new labels, right? So once you enter new attribute variable values, your model says, okay, this is related to this class, right? That is the thing what we are doing, right? So depending on the algorithm you are choosing, your data set, your pre-processing, all the factors are influence your model's accuracy, right? So if you extract a appropriate data set, if you find out appropriate variable, then only your model predict exact values, right? Correct classification is done if you consider those things, right? So first of all, right, you collect the data, then you find some algorithm, you train the model, right? Then after you train the model, you can use the testing data set and you will evaluate your model, whether that model, the first model you develop, what about that model's performance, right? To evaluate the model's performance, we are using these evaluation matrices, right? The evaluation matrix in the sense, there's nothing, right? How accurate your model is, right? What is the precision, recall, F1 score? These are the parameters we are using for uh, to examine or evaluate your model, right? So after you evaluate your model, let's say you get an accuracy of 65%, right? So 65% accuracy in the sense, right? Let's say after you are using your testing data, right? This is your model, right? You can feed this test data and you are getting some values, right? Predicted values. So based on the predicted value, let's say you have a 100 records for testing purposes, right? Then your model, let's say your model 100 records you have feed into the testing, but your model correctly predicted 65 instances, right? 65 records your model correctly predict, right? Correctly predicted. Remaining 35 your model incorrect predictions, right? So what about the accuracy? Accuracy means total predictions. Among total predictions, how many correctly predicted instances? 65 instances correctly predicted. Then multiple by 100. So this is 65% accuracy. Let's say if your model 65% accurate means if you feed 100 new data set, it will correctly predict only 65 instances. That is the meaning of accuracy, right? So depending on the accuracy, you can decide, right? So 65% is accuracy is not enough. So what you need to do, again, you can iterate the process, right? From the beginning, right? Beginning in the sense, there is something called, there is a framework, right? CRISP, cross industrial standard process for data mining. We didn't discuss that. This is the uh, framework or architecture we are using for develop some data mining task, right? Cross industrial standard process for data mining, right? So just maybe we will discuss those things. Don't worry, right? Due to the time constraint, I didn't explain in the initial classes, right? I will call for the upcoming weeks, right? So the meaning industrial, cross industrial standard process for data mining, right? This is the meaning of this CRISP DM, right? So we will discuss those things. It means nothing. They have 6 phases, right? So from the initial phase, business understanding, then data understanding, then data pre-processing. Likewise, there are 6 phases. You need to do whatever the data mining task. Any data mining task, you need to follow those 6 steps, right? So what you need to do, if you got an accuracy of 65 percentage, right? It is not acceptable percentage, right? Even for your final year research, you have got some accuracy of 65 percentage for your models. It's not a good model, right? So you need to find out what is the problem with my model, why my model shows less accuracy, right? Then again you need to start that initial stage. You need to understand your business requirements, whether all the attributes I included are appropriate for my predictions, right? Then you need to find out, is there any issues with my data set, is there any missing values, or is there any data sets are wrong data sets, or is there any errors with my data set? Then you need to think about your pre-processing, whether I did the correct pre-processing or not, right? Then you need to find out whether the algorithm I choose is related to my predictions, or whether I need to upgrade or I need to change my algorithms. Likewise, you need to step by step do some changes in your existing model. Then you need to evaluate again, right? Once you do some changes, then you can evaluate your model again, right? So once you evaluate the model again, maybe you need to check whether the accuracy is increase or decrease, right? So if your accuracy increase, then your decision that you made based on the previous results, it's correct, right? Likewise, you need to upgrade your model based on these evaluation metrics until you are getting acceptable accuracy, maybe 85 to 90 or 90 percentage. Until you are getting this one, you need to improve, right? To get these decisions, we need to know these evaluation metrics, right? Based on the evaluation metrics, we can uh, take some necessary decision about the algorithms or model we are developed, right? So this is the content what we are going to discuss today, right? There is nothing, right? Evaluation metrics in the sense, right? Uh, we already know while you are splitting the data into training and testing, right? So just imagine this is for classification, right? So if you have a classification data set, right? In your data set, let's say 1,000 instances, 1,000 records in your data set, right? For all the 1,000 records, you have a class label, right? Am I correct? If it is a classification, if you have a data set, then you are splitting into training and testing, right? For all the data set which you have, the 1,000 instances, you have some class labels, right? So once you split 80 into 20, your 80 percentage of the data have that class label. Remaining 20 percentage of the data, it means 800 instances and 200 instances, right? So all the 200 instances, you have n number of attributes, right? Let's say you have 3 attribute, attribute 1, attribute 2, attribute 3. The fourth one is the class label, right? Class label, right? This is your fourth attribute. Just think about, this is your fourth attribute, right? So for all the 200 instances, you are using the testing data 200 instances. All the 200 instances, you have a actual label, right? Actual label means that's the real label, right? So if you have attribute 1, this value, attribute 2, this value, attribute 3, this value, definitely they have this label, right? So what you need to do after you develop the model, we already discussed those things in the last class, right? After you develop the model, you are getting all these 3 columns, right? Not the fourth column, class label column. You are extracting all the 3 column and you are feed into your model. Then your model says the predicted class, right? For each and every record, your model says some prediction label, right? Your model says some prediction label, right? So then you already know actual label. Now you have some predicted label based on your model. Then you are compare these two, right? Let's say for your first record, if you have some values for 3 attributes, also you have a value for your actual label, right? So once you feed these 3 values into your model says something prediction label, right? Maybe actual label is yes, right? Predicted label also yes, right? Similarly, for the second record, actual label is no, but predicted label is yes. Likewise, you can get all the 200 labels, right? Then you can compare between these actual labels and the predicted label, right? So if you compare these two things, you can understand how many labels actually they are yes, also they are predicted as a yes. Similarly, how many labels actually they are the label is no, also the predicted label also no. Then if you do those things and mathematically calculate, that is we can call these evaluation matrices, right? There is nothing. You are comparing the actual and predicted things between your testing data set. That is we can call evaluation matrices, right? For the evaluation matrices, we are using something called confusion matrix, right? So based on the confusion matrix, you are getting some decision, right? So confusion matrix is nothing, right? Maybe in the in the x-axis you are using actual labels. In this, sorry, right? In this y-axis, if you just look at this is y-axis, then here you are put as a predicted labels, right? Here you are putting predicted labels, or maybe you can swap here actual labels, here predicted labels, right? First you need to look at that one, right? While you are doing these, right? So maybe for your final exam, I am giving you some confusion matrix and I'm asking you some questions, some basic questions, right? What is the accuracy, precision, recall? Likewise, I will ask, right? So to answer these questions, if you understand today's content, right, then only you can answer my questions, right? Okay, now we will move for the content, right? Okay, end of the session, you can understand about confusion matrix. Also, you can explain the three major things: accuracy. There's a something equation for accuracy. How we are calculate the accuracy? How we can calculate the precision? How we can calculate the recall, right? Another thing I not include here F1 score, right? Something called uh, F1 score, right? So F1 score is based on this precision and recall. By using this precision and recall, we can calculate the F1 score, right? I will explain those things, right? Don't worry. Okay, so these are the content we are discussed from these slides, right? After that, we will look at something called text mining, right? Okay. Okay, I will explain, right? Yeah, I will explain what is confusion matrix. Right? Yeah. Okay. Okay, just think about, right? One of your batchmate try to do a research, right? The research topic is employee emotion detection, right? Employee emotion detection, right? Employee emotion detection, right? So maybe just think about you are working as a software engineer, or maybe you are the HR in a IT company, right? So if you think about the IT company, that is totally different from other companies or government sector organization, right? So the output you are getting from your employees depending on their mindset, right? So if your employees are working in a healthy mind, you are getting more output from the employees, right? If your employees are very stressful, or they have so many problems, they are lack of facilities, then what will happen? They are in a big trouble, right? They have stressed. Because of that, you are getting less outputs, right? Output in the sense they are not you're not getting expected outputs, the benefits from your employees, right? So to avoid those things, as a HR manager, you're planning to develop a emotion detection system for your employees. Based on their emotions, maybe you can provide some recovery or something else, right? You are planning for improve your employees emotions, right? For that purposes, you are choose three different emotions, right? So positive emotions, maybe positive means happy emotions, right? Neutral, right? Neutral means there is he is not happy or he is not sad, right? The balance, neutral. The third one is negative emotions, right? So negative in the sense he has some sad emotions or fears, some disgust, likewise. So you need to predict three emotions: positive, neutral, and negative. For that purposes, right, you are collecting some data set, right? How you are collecting some data set, right? um, randomly you are taking some images while your employees are happy, sad, and neutral, right? So maybe they will attend a party, they are happy, right? So at the time, maybe you are take some images of your employees, right? So likewise, right, you are collecting, okay, you are collecting 3,000 images, right? You are collecting 3,000 images, right? For each emotion, you have 1,000 images, right? 1,000 into three emotions, right? So each emotion you are collecting 1,000 images, right? This is your data set, right? I will explain from the beginning, then you can easily understand what is this confusion matrix and what about this accuracy. I will explain from the beginning, right? So you need to predict three different types of emotions, positive, negative, and neutral, right? For that purposes, you are collecting a data set of 3,000 images, right? You apply 80-20 rule for splitting the data, 80-20 rule for splitting the data for training and testing purposes. Then you are getting, right, in the training phase, right? In the training phase, you have 800 into three emotions, right? Altogether, 2,400 images for uh, training purposes. Similarly, for testing purposes, you have 200 into 3 emotions, right? Then you have 600 images for testing purposes, right? So it means you have something called CNN, convolutional neural network. One of the algorithm we are using for handling with image data, we are using convolutional neural network. CNN is the algorithm, right? So for this convolutional neural network, you are feeding these 2,400 images, right? So feeding in the sense in the all the 2,400 images you have label, right? So each image is a which emotion, happy, sad, or negative emotions, or positive emotions, or neutral emotions, right? You have label, right? So that is your class label, right? For each image you have a label, right? Whether it's a positive mindset or negative mindset or neutral mindset, right? Based on these, right? Once you feed these 2,400 images for your algorithm, CNN algorithm, right? It will train with these 2,400 images, and it will develop some models, right? So you are developing some model, right? So your model, in the sense, your model extracts some features. The beauty of convolutional neural network, here you don't need to provide the features, right? If you are using convolutional neural network, you don't need to do the feature extraction, right? So whatever the research, maybe if you are doing a classification with decision tree, you are the one define what are the features, what are the attributes you need to use for this classification, but not the case in convolutional neural network. In convolutional neural network, by themselves, right? Automatically, they will extract the features. That algorithm have the facility to extract the features from the images you are feeding to your model, your algorithm, right? If you feed the images, the different emotion images for your CNN algorithm, what will happen? It will extract the features, right? If it is a happy, these features they will extract from the images. If they are angry, or if they are positive emotions, if they are negative emotion, each emotions, they will extract some specific features from the images, right? So based on that features, it will develop a model called, let's say it develop a model, right? Then what will happen? You have remaining 600 images, right? So then you can feed this remaining 600 images one by one, right? You can feed this 600 images uh, one by one by one to your model, right? So if you feed your first image, then already you know remaining 600 images also they have some label, right? For each image, yes, you have actual label, right? Actual label in the sense, actually the first image you are feeding into your model is a happy image, positive image. The second image you are feeding into your model is a negative emotions. The third image you are feed into your model is a neutral. Likewise, each and every 600 images, you have some actual classes, right? Actual label, have positive or negative or neutral. Likewise, you have actual label, right? Then you hide that actual label without putting that actual label. Just you feed only the 600 images one by one to your model. Then your model tells something, right? Your model predict the emotion, right? let's say if you feed your first image, actually that is a positive emotion. Maybe your model predict as a neutral emotions, right? Likewise, your model predict all 600 images with some emotion. Those emotions we can call predicted emotions, right? Then already you know that image have a specific label. Also, now you are predicting some labels. Then you compare the actual label and predicted label, right? So that comparison is called evaluation metrics, right? So how we are compare those actual and predicted classes? For that purposes, we are using a matrix. That matrix is called evaluation matrix. Sorry, confusion matrix, right? So already you have 600 images with a specific label. That label we can call actual label, right? Actual label. For each 600 images, once you feed your model, here you have some label. That label we can call predicted labels, right? Then you compare actual labels with predicted label, right? So that comparison, we need some matrix. That matrix is called confusion matrix. For that matrix, we can call confusion matrix, right? So that matrix we can call confusion matrix, right? I will explain how we can generate the confusion matrix for this scenario, right? Okay, I will wipe the things, then easy for you. Okay, the confusion matrix is nothing, right? To generate the confusion matrix, you need to know how many class labels you are doing, right? In this scenario, we have three labels, right? Uh, positive, positive, negative, and neutral, right? So better I put as a positive as a plus positive, minus negative, then neutral, n, right? N is neutral, right? Okay, then you have three emotions, right? Okay, just think about this is the actual label, right? Actual, actual label, right? Actually, I have three label: positive, negative, and neutral. Similarly, here I can generate predicted labels, right? Predicted labels, right? Here also I have three, right? Here also I have three, right? This is predicted positive. This is predicted negative. This is predicted neutral, right? Once you generate this table, that is we can call confusion matrix, right? Did you get my point? So the comparison of actual labels with predicted label, we can call that is evaluation, right? For that evaluation, we need a matrix. That evaluation matrix is called confusion matrix, right? So the confusion matrix in the sense, in one axis, you need to include actual labels. In another axis, you need to include predicted labels. Right here in the x-axis, I am putting actual labels. In y-axis, I am putting predicted label. It's not mandatory for x-axis for actual, y-axis for predicted. Maybe you can change x-axis for the predicted label, y-axis for the actual label. It's up to you. You are the one decides, right? But you need to clearly mention what is actual, what is predicted, right? Now I'm asking you some area, some cells. Tell me each cell belongs to which purposes. Okay. Now tell me about this space. Tell me about this space, this area. What is this actually? Tell me. What is this area? Anyone? So I already told you, right? This is actual emotion labels. This is predicted emotions labels, right? So tell me if I put a number, right? So altogether we have 600 images, right? So 600 images we are using for the testing purposes, right? Okay, tell me the sum of, okay, let's say this is A, this is B, this is C, D, E, F, G, H, I, right? Okay, now tell me, okay, what is the sum of these? Tell me, what is the sum? Tell me, do you get what I'm telling here or not? Not did you get my point, what I'm telling here? I explained this real world scenario, right? Your emotions, predictions, right? So you have 2,400 images for training purposes. You are using 600 images for the testing purposes, right? So what is the total number? Yeah, very good. Yeah, someone tell the answers, right? What about others? So what is the total number of instances you are using for this confusion matrix? Tell me. What is the total number of instances? You guess and tell me the answer. Tell me. Tell me. A plus B plus C plus D plus E plus F plus G plus H plus I. What is the sum of those 9 values? I already told.
2400, sir.
Sorry, 2,400. How many of you tell the same answer? Raise your hands. So just raise your hands if you tell the answer is 2,400. What about others? Just turn on your mic and talk, right? Actually, this is not an easy subject, right? This is a difficult subject, right? That's why I am asking you questions, right? Otherwise, you understand in difficult, in incorrect way. You understand, right? That impact your final exam results, right? Yeah. 52, your answer is correct, right? 90, your answer is 090, your answer is correct, right? So what is the sum of A plus B plus C plus D plus E plus F plus G plus H plus I? If I get the sum of these 9 values, 9 cell values, what is that? At least guess, right? Maybe that is 2,400 or 600, right? So which one? How many of you say it's a 600? How many of you say it's a 2,400? Tell me. One of that answer, right? At least you need to guess that one, right? Yeah, it's correct. 069. It's correct. Yeah. Up to now, I'm telling that one, right? Comparison of actual labels and predicted labels, right? For which, so I from the beginning, what I told, you are using 80% of your data for the training purposes, remaining 20% of the data for the testing purposes, right? So we are not evaluate with training data, right? So we are evaluate with testing data, right? So 20% of the data, they have actual labels. Then we have uh, pick the labels for that 20% of the testing data, then we are compare the actual labels and predicted labels of testing data, right? So it means here how many testing data? 600 images, right? The sum of these A to I is equal to 600, right? So the total number of instances we are using for this evaluation matrix equal to 600, right? Okay, now tell me, what about this A, right? So yeah, wait a minute. Okay. Okay. Here, if I put 85, then what do you mean by this 85? Tell me, what do you mean by this 85? So this is actual label. This is right. This is actual label. This is predicted label, right? Now tell me, what is this 85? If I put 85 here, what is the meaning of this 85? Tell me. Just guess and tell me the answer first. What is this 85 means? So here 85 instances, right? I am putting, right? So all these 85 images are what? What is the meaning of that 85 images? Tell me with that column names. That's what I am asking you. Just take that columns, the name, predicted label and actual label. Tell me what is this, right? Here we predict three different types of emotions, right? So what is this emotion belongs to? What do you yeah mean 200, yeah, 200 emotions, right? Yeah, there are so many answers, right? So if you tell the answer for this one, right, maybe someone says predicted 85. So predicted 85 is what, right? So that is 069 in your answer. That is not a full answer, right? You are telling predicted 85, right? So what is this predicted 85? Tell me. Yeah, positive, right? Yeah, someone says 85 out of 200, right? That is correct, but that is what, that is important, right? So someone says accurate table, accuracy, right? This is not an accuracy, right? So accuracy, we need to think about the accuracy for all three different labels, right? Here, this 85 in the sense, just I will tell the answer, right? The 85 means, right? These 85 instances, they are actually, they are positive emotions. Also, these 85 instances, your model correctly predicted as a positive emotions, right? So if you look at here, they are actually positive emotions, right? So here, this is actually positive emotions. This is actually positive emotions. Also, these 85 instances, your model correctly predicted as a uh, positive emotions, right? That is this 85. right? Okay, now tell me about this one. Hmm? What about this one? Okay, now I'm putting here as a okay, here I'm putting as a 185, right? So I'm putting as a 185 correctly predicted, right? Or 180, right? Just think about here 180. Here I'm putting as a 15. Here I'm putting as a 10, right? Okay. Now tell me what about this 15? What do you mean by this 15? I need that explanation. Tell me.
The actual label is 50, sir, but the model will be predicted as a positive 15.
Yeah, actually, those 15 instances are negative emotions, right? Minus mean negative emotions, but your model says as a positive emotions, right? Your model predict these 15 instances, 15 images as a positive emotion. What about the 10? 10?
Actual label is the neutral emotions, but the model
They
will
are
be
predicted
predicted as a 10.
as a positive, right?
Positive.
Okay. Okay. Now tell me, right? This one. Yeah, 5 instances. Okay. Here I'm putting as 175. Okay. 10 and 5. Okay, now tell me what is this 175? Actually, they are negative emotions. Your model predicted as a negative emotions. What about this 5? This 5 in the sense, actually, they are neutral emotions, but your model predict as a negative emotions, right? Give me a minute. Okay. Yeah, now I think it's fine, right? Okay, now tell me, uh, what do you think about the sum of these first row, not column, right? I'm asking you about this column, right? So I'm asking you about the sum of these column, sum of this row, sorry. So what is the sum of this row? Is it correct or wrong? Hmm? So based on the scenario, right? You already know we have 600 instances, right? So now you need to check the sum of all the cell values and tell me is it correct 600 or not? Tell me. So maybe for your final exams, right? I'm giving you a scenario, right? I am giving you a scenario, right? Scenario means they're similar to this one, emotion detection. Then we are splitting 80-20, total number of instances I have. I'm giving you some numbers, values, and I'm asking you, right? Or I'm giving you 4 or 5 different confusion metrics. I'm asking you pick the correct confusion metrics for this scenario, right? So to find out the correct confusion matrix, if you know the basics about the confusion matrix, then only you can find out the correct confusion matrix. Hmm? So what do you think about the sum of the first row? What is the sum of the first row? Tell me.
205.
205. Is it correct or wrong?
It's wrong.
Correct or wrong? It means it's possible or not? Tell me the answer. I need the reason, right? No need answers, right? If you tell it's correct, then tell me why you are saying that one. Then if you tell it's not correct, the sum is wrong, right? The sum 205, not possible to come here 205. Then why you are telling that one? Why? I need that reasoning, right? No need the answer. Tell me the reasoning, why you are telling that way. Just turn on your mic and tell me. Right? Maybe you can talk, right? Otherwise, it's depending on your interest on the subject. I go in more depth level. Otherwise, I will teach them basics and I will stop the session, right? That's the thing happen, right? Depending on your batch capabilities as well as your interest on the subjects, we are go for more depth level, right? Otherwise, we will teach them basics and I will stop the subjects. That's the thing happen, right? So I'm asking you a very interesting question, right? So what do you mean by the first row? First row. What do you mean
Predict
by?
possible positive emotions.
Yeah, your model predict as a positive emotion. The first row explain the total number of instances your model predict as a positive label, right? That is the first row. First row explains the total number of instances your model predict as a positive emotion, right? That is the meaning of that first row, right? The total number of instances 205. Is it possible or not? That is my
It's
question.
possible, sir.
Hmm?
It's possible, sir.
Why? So I told you 200 emotions for three, 200 emotions for each, right? 200 images for each emotions, right? Then how it possible? Just
Sir,
argue and tell me.
that's a predicted label, no, sir. So don't we no need to
Yeah,
confuse
very
it.
good, very good. Yeah. So that 200 for each emotion is the actual labels, right? So here, this is a predicted label, right? The first row is a predicted label, right? That can be varying, maybe exactly 200 or more than that or less than that, right? It depending on the model's accuracy and model performance, right? Depending on your how you train your model's performance, it will vary, right? Maybe you are getting exactly 200 or more than 200 or less than 200. It is varying, right? But this 600 for each emotions, 200 images in the meaning of that one, that is actual labels, right? So now tell me, so if it is actual label means definitely for each column, right? Definitely for each column must have 200, right? This is mandatory, right? If now you need to check each column they have 200 or not. If you find out anything less than or greater than 200, it is the wrong confusion matrix, right? So based on that, maybe normally, right, some of your senior badges, they will do some forgeries, right? They don't know the knowledge of these things, right? So they are capturing from the internet and just put the confusion matrix. Last time also we find some theses, right? Then we put repeat, or maybe we put C marks, right? The reason they don't know the internal mechanisms, right? So actual label is he put the testing data as a something, but he if you look at this his confusion matrix, it's a different thing, right? So depending on that, they will we will find them, right? Who are the cheaters, right? So don't think those ways, right? So if it is actual label, definitely it must be 200 for each emotions. Why I am telling here, I'm clearly mentioned in the question, uh, I have 3000 images, 2400 images for testing, 600 images for, sorry, the 600 for testing, 2400 for training. Among the 600, each emotion have 200 images, right? Each emotions, 200 images we have. So the meaning of that one, for each emotion. So if you look at here, the positive emotion, here also 200, negative emotions, 200, the third one, neutral emotions also 200. You need to get the sum, 10 plus 5 plus 185, 200. 15, 175 plus 10, 200. 180, 10, 10, 200, right? So only the actual label, it must be accurately 200 for each emotion, but not the case in predicted. Maybe they will varying, right? So they may not exactly 200, maybe less than 200 or greater than 200. If you look at the second row, they have 190, right? Total number of instances, 10 plus 175 plus 5. So 190. If you look at the third one, 10 plus 10 plus 185, third row. So that is equal to 205, right? Here 205 instances, here 190 instances, here 205 instances, right? So maybe for predicted label it's possible, right? But not the case in actual label. So depending on these some values, you can find out the most appropriate confusion matrix, right? Okay, now tell me, now we will look at what is accuracy, precision, and recall based on these, right? Now tell me, okay. Okay, now I will explain, right, accuracy in the sense, right? Now we will look at one by one. Okay, now we will keep this one and move for some other slides, right? So now, if you look at the slides, right, just look at here, the same thing I'm explaining here, right? So without numbers, I'm explaining with, sorry, some letters, right? So if you look at here, this is actual label, right? This is predicted label, right? It's up to you. You are the one decide which axis for which actual or predicted, right? Maybe you can put actual as a x-axis or y-axis. It's up to you, right? Here, this is maybe cluster one means class one, right? Cluster two means class two. Cluster three means class three. Here also class one, class two, class three, right? So this class one, class two, class three, we can call as a predicted classes. This cluster one, cluster two, cluster three are actual classes, right? So here the total number of instances, right? N11, N12, N13, N21, 22, If you get the sum of these N11, N12, N13 plus N21, 22, plus N231, N32, 33, all it is equal to N, right? That is the total number of instances in your test data. Right? Okay, this is some example images, right? So for these images, we will calculate accuracy, precision, and recall, right? So they are explaining N means the number of data points, right? The total number of instances in your testing data, right? How many records you are using for the testing purposes. That is N, right? That N is equal to C1, C2, C3. Why I am telling C1, C2, C3? So C1 is the sum of N, sorry. C1 is the sum of N1 plus N2 plus, sorry, N11 plus N21 plus N31. So the sum of these three is equal to C1. C2 means the sum of these three, right? C3 means N13, N23, N33. The sum of these three is equal to C3, right? So if you get C1 plus C2 plus C3, that is also equal to N. Or maybe the sum of this one, M1 plus M2 plus M3 in the sense, the sum of that each row, right? So 1, 2, 3, N11, these three, sum of these three is equal to M1, sum of these three is equal to M2, sum of these three is equal to M3, right? So if you look at the previous example, right? So if you get the sum of each column, 200, 200, 200, so altogether 600 instances, that is one way we can calculate, right? Another way, we can get the sum of these three. First row, 205, right? First row, 205, second row, 190, third row, 205, altogether for 600, right? So maybe you can get the sum of all the columns, or maybe you can get the sum of all the rows, right? So that's the way we can calculate the total number of instances, right? So they are explaining what is this, right?
Yeah.
Okay.
So,
Okay. Yeah, tell me.
so while considering the previous one, it was wrong right now, sir. While considering this table,
No,
both.
it's correct. Why you are telling that way?
Because the actual label is here exactly same, sir. But in the next one, it is varying now, sir.
It means
For the
predicted
count
label,
of the
right?
actual label. In the next slide.
Yeah. Next slide, right? So
Yes.
yeah, give me a minute.
In this actual label is varying now, sir.
Yeah, 100, 90, 1500, 85, 100. Yeah. So it means we need to swap the labels, right? So here, anyone notice this one? Very good. He find out, right? Anyone notice something here? So why I'm putting this one? Maybe this is a wrong confusion matrix, right? So I will ask you this type of questions, right? So I'm giving you a scenario. It explain all the things, right? Then I'm asking you an MCQ question or some questions. I am giving you four different confusion metrics. I'm asking you find out the correct confusion matrix. Uh, Define or write the reason why you are omit the rest of the three, right? So to find out the correct confusion matrix, you need to know those things, right? So anyone notice something here? He noticed something. Hmm? Anyone notice something here?
Yes.
What about others? If you notice here, right here, I already told you, right? Yeah, in this question, I didn't explain anything, right? So maybe we cannot consider this, right? But actual thing, right? Normally, we are using a balanced data set now. So if you look at the get the sum of these three is 100. Here the sum of three is 100. Here the sum is 100, right? So here each one is 100 in the sense. So normally this is not a predicted label. Normally this is an actual label, right? This is a predicted label. That is the most acceptable label. So this one is the predicted label. By maybe predicted labels, we have different number of values are also possible. Here 90, here 110, 110. Right? Normally, while you are doing a testing, you need to use a balanced data set, right? If you are using imbalanced data set, that imbalanced data set also influence your results, right? Your model's performance, right? So what I'm telling here, right? Let's say in the previous example, in the previous example, right? For each emotion, let's say for the positive emotions, you are using 1500 image. Sorry, maybe positive emotions, you are using 2000 images. 500 images for negative, 500 images for positive. If you are using this ratio for each emotions, definitely your model accurately predict only the positive emotions, right? Because they have more instances. They learn more knowledge about only for positive emotions, right? They have lack of knowledge in the negative and neutral emotions, right? So that's why while you are doing a model training or model development, normally you need to balance your data set, right? If you are using an imbalanced data set, that imbalancing your data will affect the prediction accuracies, right? The predictions model performance varying because of this imbalanced data set, right? So just think about always you can use balanced data, right? So balancing data balancing is a different subject, right? Maybe there are different techniques to balance your data, right? You can find some those things from the internet, right? I can't explain each and everything, right? Maybe one my research students, at the time I will explain those things, right? If you want, these are some questions, right? Maybe if you do a data mining related research, definitely in the panel, they will ask these type of questions, right? You are using imbalanced data, then how you can say your model will perform well? Because of that imbalancing, your model's performance vary, right? You're not getting uh, a good model, right? So likewise, there are so many things you need to consider, right? Here, what is the problem here? Normally for actual labels, you are using equal number of data set, but here this is says this is a predicted, but not this is wrong, right? Here I need to put actual, right? Very good. Here this is predicted, right? If you change these two, it's fine, right? Okay. In this example, we have three classes, right? So now if you look at this is also a confusion matrix, right? So now if you look at this one, this is also a confusion matrix, right? Now tell me, what about this one? How many classes you are predicting from this? Tell me how many classes you are predicting from this? How many classes you are predicting from this?
4, sir.
Yeah. Yeah, tell me how many classes you are predicting?
2, sir.
Yeah, 2 classes. What about others? So maybe I'm asking these type of questions, right? So I am giving you a confusion metric. I'm asking you how many classes or how many class labels in your data set? What are the possible values for your class label? 2 classes, right? One is positive, one is negative, right? Maybe just think about, or maybe I'm asking you, write a scenario. Okay, maybe just look at here. I'm asking you a scenario for this confusion matrix, right? So scenario means some phenomenon, right? For which research you get this confusion matrix. Tell me a real world example. Maybe this confusion matrix for COVID test, right? COVID-19 test, right? So maybe you are selecting a particular area, right? Maybe for that area you get all the populations or all the school childrens. Maybe you need to define a boundary for your population. So for that population, you need to take COVID test, right? So so at that time, COVID test, you are getting positive and negative results, right? So practically, what you can do, right? Let's say if you do this type of research, what you need to do, first of all, you need to find a population. Let's say you are getting a population of 1,500 male and 500 female, right? That is also, I'm maintaining the balance, right? Equal gender equality, right? 500 for male, 500 for female, right? Why I'm putting, if you do a ratio, or if you do different ratios, if you imbalancing, that also impact your results, right? That's why I'm using balance thing, right? So maybe the olive oil area, I'm taking 500 samples for 500 university students, male students, and 500 female students, right? Then I'm taking positive COVID tests, right? Maybe I'm taking more COVID tests. Among those COVID test, I'm taking 500 positive, 500 negative, right? So then I am taking some other parameters, right? If you do this type of research, you need to take the parameters, right? There are immunities, there are WBCs and some other testers, right? Depending on that, I create a data set, right? So here, you don't need to worry about that much, right? If you look at the confusion matrix, depending on these uh, different columns or different cells, you can say what are the possible uh, outcome for this class label. So one outcome is positive, one outcome is negative, right? So this is prediction, right? This is actual. So actually they are positive. Actually they have COVID-19. Actually they don't have COVID-19. But here, maybe by using some parameters, their blood pressure, their humidity, their some other parameters, your developer model. So your model says this is positive, right? So this is positive based on the prediction. This is negative based on the predictions, right? So now tell me, what about this one? Hmm? So if you look at the population, actually some patients, some people positive for COVID-19, actually some patients negative for COVID-19, right? So let's say 100 students actually COVID positive for them. 150 students actually they are negative for the COVID-19, right? Now tell me what is TP. So if now, okay, now I'm asking you a question, right? Now I'm asking you a question, right? Tell me how many instances your model predict correctly? Your model predict correctly. Tell me how many instances. So how many instances in the sense, tell me the letter. Get the sum of uh, which elements it is a correctly predicted. 2 or 3. I don't know how many instances you need to get the sum. Tell me what are the instances. I get this sum of these instances to find out how many instances your model correctly predicted.
Two,
Please
sir.
tell me how many instances your model correctly predicted.
Two, sir.
Two, sir.
So what are they?
TPTN,
Yeah, TPN,
TN.
true positive, true negative, right? So that green cells. So if you look at the green cells, right, that is the correctly predicted in the sense, actually, if you look at this true positive. So if you look at this true positive, right, actually, the patients or the students coming under this cell, actually, they are positive for COVID, right? Actually, they are positive for COVID. Also, your model also predict as a positive, right? Actually, they have COVID. They have COVID positive. Your model also predict as a positive, right? So that is a correct prediction, right? Actually, they have positive for COVID. Your model also predict as a they are COVID positive, right? Similarly, if you look at the TN, true negative, actually they are negative for COVID. COVID, they don't have COVID, right? They are negative for COVID. Or your model also predict as a negative for COVID, right? So if you get the sum of true positive plus true negative, that is the correctly predicted instances. By using your model, the trained model, correctly predicted instances, right? So how about this one? False negative. Tell me, how about this false negative?
Incorrectly predicted ones.
Actually, correctly predicted ones means what? So that is not the thing, right? Correctly, I need that explanation, right? Actually, they have COVID positive, but your model predict as a COVID negative, right? That's the thing. Just look at this exact cell, right? Actually, right? Actually, they have positive for COVID, right? It means in their body, COVID symptoms are there, but your model predict as a they don't have COVID. That is the meaning of negative, right? So your model incorrectly predicted, right? This is a wrong prediction, right? What about this one? So if you look at the real scenario, right? Real scenario, what will happen? Already in their body, they have COVID symptoms, but your algorithm or your model you developed or you generated a model, that model says they don't have COVID. That is the meaning of false negative. Similarly, what do you mean by this one? It means this group of people, false positive means actually they don't have a COVID positive, right? It means they don't have COVID in their body. There is no any symptoms or there is no any germs or any viruses in their body, but your model says they have COVID, right? Actually, they don't have COVID, but your model says they have COVID, right? That is the meaning of these four cells, right? Okay, now tell me, accuracy. Now we will look at one by one, right? Now you know some basics, right? So to find out correctly predicted instances, you need to get the sum of these diagonal element, right? So if you get the sum of these diagonal element, the sum of these diagonal elements belongs to correctly predicted instances, right? You need to remember that point, right? Okay, now we will look at for what is accuracy, right? Read the definition. Accuracy means the percentage of correct classification, right? So the percentage of correct classification is called accuracy, right? So based on the definition, we can get an equation for accuracy. So total number of instances, among the total number of instances, how many instances it will correctly predicted instances, correctly predicted instances. So total correctly predicted instances in the sense, the meaning of that one, actually they have the same label. Your algorithm also predicted as a same label, right? That is the meaning of that one, right? So if you look at this example, or if you look, yeah, sorry. If you look at this example, right? If you look at this example, right? Actually, they have positive. Your model also say as a positive. This is correctly predicted for positive. Not only for positive, right? You need to think about the negative as well as, right? Actually, they don't they have negative for the symptoms. Your model also predict as a negative, right? So if you get the sum of these true positive plus true negative, the sum of these two together, we can say that is correctly predicted instances. Then if you divide it by correctly predicted instances divided by total number of instances, right? For this confusion matrix, how many total number of instances you are using. So if you get this ratio, this fraction, that is accuracy, right? So this accuracy gives you 0.0 to 1.0. Among these you are getting, right? So then if you get multiple by 100, this is the percentage of your accuracy, right? So any questions to find out the accuracy? Accuracy means total correctly predicted instances divided by total number of instances, that is equal to accuracy. Okay. Okay. Now tell me for this emotion detection, what is the accuracy? Calculate the accuracy and tell me.
Yeah. 90%, sir.
%90.
What about others? Someone says 90%. How you can calculate? Tell me. Okay, someone says the accuracy is 90%. What about others? Calculate and tell me your answers as well. each and everyone try and tell me the answer, right? I will ask randomly. What about others? Tell me the answer. Your answers are 90%.
90%,
I need
sir.
how, yeah, I need to know how to calculate. That is what I need, right? So to calculate the accuracy, right? To calculate the accuracy, I already told you. So total number of instances, we already know 600, right? So maybe you can get the sum of all the rows or sum of all the uh, columns, right? So 600. Out of these instances, how many correctly predicted instances, right? That is we can call accuracy, right? So correctly predicted instances means this one, right? This is positive, actually positive, predicted also positive, actually negative, predicted also negative, actually neutral, predicted also neutral. So get the sum of 180 plus 175 plus 185. So then accuracy is equal to 540, right? 540 divided by 600 multiple by 100. Yeah, if I cut this one, 90% accuracy, right? This is the way we can calculate the accuracy, right? Any questions? Okay, now you know about accuracy, right? Now we will look at what do you mean by precision, right? So if you look at the precision, right, the percentage of relevant members in the cluster, right? So precision means that is related to predictions, right? So precision in the sense, right, among total predictions, how many correctly predictions are happen? The ratio between total predictions among the total predictions, how many correctly predictions, that ratio we can call precision, right? Okay, if you look at here, right, in this precision, right, if you look at the accuracy for entire model, we will find out the accuracy, right? So entire model, you have an accuracy, right? So in that accuracy, you include all the different class values, right? Here we are include positive and negative. In the previous example, we use positive, negative, and neutral. All together, we have include all the three correctly predicted instances together sum, and we will find out the accuracy, right? But not the case in precision and recall, right? For precision as well as recall, we need to calculate separate precision for each class, each label, each label value. You need to calculate separate precision or separate recall, right? So now we are look at the precision of precision in the sense that is related to predictions. So both are P, right? So you can remember easily. This is prediction start, precision start with P. Predictions also start with P. Then you don't remember these. You don't forget these, right? So precision in the sense, the ratio between the predictions, right? The ratio between the predictions, right? The ratio between the predictions we can call precision, right? So to calculate the precision, right? If you look at this confusion matrix, right? I already told you we can separately calculate the precision for class level, right? So now we need to find out the precision for positive class, as well as we need to find out the precision for negative class, right? So for each class label, we will calculate the precision separately, right? So the precision in the sense I already told you, right? Precision means total predictions, right? Among the total predictions, how many correctly predictions are happened, right? Now I will explain what do you mean by these total predictions. Let's say now I need to calculate the precision for positive class, right? Now I need to calculate the precision for positive class, right? So positive class precision in the sense that is related to predictions, right? So predictions mean this is column based, right? So the total predictions as a positive class means the sum of these two. Is it correct? So I already told you precision means that is related to predictions, right? So here, if you look at this confusion matrix, predictions are denoted by columns, right? So this is for positive predictions column. This is for negative predictions column, right? So the precision for the positive class in the sense, you need to get the sum of how many total predictions happen as a positive, right? So total predicted instances as a positive. How many total instances your model predict as a positive, that is comes under bottom part, right? Total total prediction as positive, total prediction as a positive. Among the total predictions, how many correctly predictions means actually they are positive, predicted one also positive, right? That is correctly predicted. So total predictions means that is the sum of correctly predicted or incorrectly predicted, right? So if you look at this column explain, right? Correctly predicted, right? Correctly predicted mean actually they are positive, predicted also positive. But here, actually they are negative, but your model predicted as a positive, right? So the sum of these two we can call total predicted. Among this total predicted, this is the only one correctly predicted. So the ratio means uh, true positive plus false positive over, sorry, true positive. True positive means among the prediction, correctly predictions is true positive over true positive plus false negative. That is total prediction. This scenario is equal to precision of positive. Now tell me, what about the precision of negative? Precision of negative, how you can calculate the precision of negative? How you can calculate the precision of negative? Tell
If
me.
you want to find the total negative prediction, sir, best
Precision of negative is
negative,
equal
then
to total prediction as a negative, right? Previous case, total prediction as a positive. Here, total prediction as a negative. So it is equal to false negative plus true negative. Then in the top, you need to put false negative. Is it correct?
no, sir, true
False negative
negative,
FN?
sir.
True negative. Very good. So in the top element, we need to tell only correctly predicted. So here, the correctly predicted instances are this one, right? So among the total predictions, true negative is the correctly predictions, right? So this is we can call precision of negative, right? Okay. Now, can you calculate for this one? So here, how many precision you need to calculate? Then tell me what are the values for each. Yeah, sorry. Yeah, I turn on the mic and speak, right? Sorry for that. So yeah, okay. Now I am asking you a question, right? Now I need to calculate the precision of positive, right? My question is I need to calculate the precision of positive, right? So I need to calculate the precision of positive emotions, right? Now tell me whether I consider first column or first row. Which one I consider?
First row, sir.
First row. Why? Precision is
Yeah, sir.
related to
It's the
predictions.
the
Yeah,
predicted value, sir.
yeah, predicted values. So now what I need to do, I need to consider the first row, right? So the first row, I need to calculate how many total prediction as a positive. How many total prediction as a positive? 180 plus 15 plus 10. So altogether sum of these 180 plus 15 plus 10 total prediction as a positive. Among these, I need to find out correctly predicted positives. Correctly predicted positive is equal to 180. So 180 divided by 195, right? Then if you multiply 180 divided by 195 multiple by 100. So what is the percentage?
205, sir.
Sorry?
205, sir.
Yeah, sorry. 180 plus 15 plus 10, right? 205 over 180 multiple by 100. So what is the value? So maybe you're getting around,
87.
sorry,
87, sir. 87%.
87, right? Yeah, yeah, maybe you can calculate the value, right? So that is the way we can find out the precision for positive, right? Similarly, we can calculate the precision for negative. How we can calculate the precision for negative? You need to think about the second row, right? 10 plus 175 plus 5 over 175. That is the correctly predicted. Then multiple by 100, right? So then 175 over 190 multiple by 100. That is equal to precision of negative class, right? Similarly, I can calculate the precision of neutral class. Precision of neutral class is equal to, you need to get the sum of all the rows in the third row. 10 plus 10 plus 185 over 185, right? So then multiple by 100, right? So it means 185 over 205 multiple by 100, that is equal to precision of neutral class, right? That is a way we can calculate for precision, right? So precision that is related to predictions. Among the total prediction of a particular class, how many correctly predicted? That ratio is equal to precision, right? So the next thing is recall, right? So previously, we consider total predictions. Among the total prediction, how many correctly predictions are happened for each class? That is precision, right? Recall in the sense that is related to actual instances, right? Actual instances, actual, real instant label. Among the total actual instances, how many correctly predicted instances? The ratio between correctly predicted instances and the total uh, actual instances, that is equal to recall, right? So if you look at here, previously in the predictions, we consider predicted predictions, right? So previous case, we considered this one, right? So total predictions among correctly predictions, right? This is we are considering. Now, if it is a recall, right? Actually total positive. So here also we need to separately calculate the positive and negative, right? So if I want to calculate the recall for positive, I need to find out how many actual positive are there. How many actual, this is actual. How many actual positive are there? Among these, how many correctly predicted positives, right? So actual positive means true positive plus false negative. True positive plus false negative is the actually positive. Actually they are positive values, but your algorithm predict as a positive, they are true positive. So then if you multiply by 100, that is the percentage for recall. Similarly, if I calculate the recall for negative, right? So I need to find out actually how many negatives are there. So false positive plus true negative. Among these, how many correctly predicted negatives? So true negative. So this ratio we can call recall, right? Recall also we need to calculate separately. Okay. Now can you calculate the recall for this one? Calculate the recall and tell me. What is the value? Here also we need to calculate the three different recalls, right? So tell me how you can calculate the recalls.
In this case, we want to look the column wise, sir.
Yeah, previously we look at row wise. Now we need to look at column wise, right? Very good. So if you look at the recall for positive, total total actual labels 200, right? We know each and every one 200. So 200 over 180 multiple by 100, right? So then this is 90%, right? Similarly, recall for negative 200 over 175, then multiple by 100,
87.5%.
87.5%. Similarly, recall for the neutral class 200 over 185, 92.5%, right? So these are the recall values, right? The next one is F1 score. Yeah. The F1 score in the sense, here also we need to calculate the F1 score separately for each label value, right? For the F1 score for positive, then what you need to do, 2 multiple by precision of positive multiple by recall of positive over precision of positive plus recall of positive, right? 2 into precision multiple by recall divided by precision plus recall. That is the equation for calculate the F1 score. Then as a homework, you can calculate for that table, right? Precision and recall values, right? Okay, yeah. Okay, don't think about that 100 and that part, right? So just keep it the same here, right? This is actual, this is predicted, right? Maybe in this research that student using imbalanced data set. Just imagine this student using imbalanced data set, right? Because of that, he gets some miracles and something, right? So now can you tell me the precision and recall for this confusion matrix, right? So first tell me what is the accuracy of this one? Accuracy, how you can calculate the accuracy? So total number of instances, 90, 110, 100, 300. Over accuracy means what? This one, this one, this one. So what is that? 2 plus 12 plus 7. So the accuracy is 21 divided by 300. So this is multiple by 100. Then
It's 7%.
how many?
7%, sir.
7, right, sir? It's 21, sir.
Yeah, 21 over 300 multiple by 100, right? So then cut down. Yeah, sorry. So 7% accuracy. This is not a good model. This is a worse model, right? So if you test 100 records with your model, only 7 records, it will correctly predict. Rest of the things, it incorrect predictions, right? It means that model is useless, right? So we need to improve the model by changing the parameters, right? Okay, now if you want to calculate the precision, right? So precision is related to predictions, right? So in the precision, you need to think about the column wise, right? So this column wise. So precision of class 1, C1, class 1 we consider as a C1. So 2 plus 8 plus 90. So it is equal to 100 over 2. Similarly, precision of class 2, 100 over this one, 12. Precision of class 3, 7 over 100, right? This is precision, right? Similarly, if you look at the recall, right? So recall is related to actual recall of class 1 mean actual how many instances over correctly. So 2 over 90, here 12 over 110, this one. Here 7 over this 100, right? So this is the way we can calculate the recall values. Then if you get the 2 into F1, F1 score is equal to 2 into precision into recall over precision plus recall, that is equal to F1 score, right? Okay, now this is correct one, right? Can you calculate now? This is the correct one, right? So now actually balanced data set 300, predicted is varying. Now can you calculate? What is the accuracy now? The same accuracy, right? 2 plus 12 plus 7. So 21 divided by 300. So 7%. So now what about that precision? Precision of class 1. Precision of class 1 means predicted. So this one. So 90 over 2. 2 over 90 is precision, right? Precision of class 2, 110 over 12. Precision of class 3, 100 over this one, 7. Right. Similarly, if I look at the recall of class 1, so recall is actual, right? Recall is actual. Now we need to think about this way. So 100 over 2. Similarly, recall of class 2, 100 over 12, right? Recall of class 3, 100 over 7, right? So these are the recall values, right? Okay. Now can you try this one? Can you try this one and tell me what about the accuracy? Accuracy? Tell me the accuracy. Okay. Tell me the accuracy. Each and everyone tell me the accuracy now. Please try each and everyone. Tell me the accuracy. If you understand, then only you can answer this question. Tell me the
29%.
accuracy. How many? Someone
20.
says 29. Is there any other answers? Okay, someone says 29%. What about others? So accuracy. Tell me how you can calculate 300 over
Correctly
20
predicted.
plus
Correctly predicted value.
20
0
plus
plus
42.
27.
Is it correct? Is it correct? That's why I asked you this
Yeah.
question.
But
So it
not
becomes
balanced
correct.
data, sir.
No. What about others? Each and everyone calculate and tell me the answer. Before tell me the answer, try each and everyone. Otherwise, I will ask randomly. Okay, each and everyone tell me the answer, right? I'm giving you 1 or 2 minutes. Tell me the answer, each and everyone. You did some mistakes. That's why I told you. What is the mistake here? Look at the confusion matrix carefully and tell me the answer. This is wrong.
Yeah,
20
the
plus
confusion.
4.
Yes, sir. The order is wrong, sir.
Yeah, that's why I told you, right? So don't just think or just remember only diagonal element, right? So that's the thing happen. Just you get this diagonal element, sum of this diagonal element without considering anything, just get the sum. That's a problem, right? Not always you are getting the same question, right? They have some tricks. Your exam paper full of tricks, right? So don't expect the same way how we are practice here, right? So here what will happen? The labels are in the reverse order, right? So if you get this one, this is not correct one, right? So the meaning of this one, actually this is class 3, predicted as a class 1, right? So here you need to look at this one. Actually this is class 3, predicted also class 3. This one, then this one. So you need to get the sum of accuracy, 38 plus 42 plus 35. divided by 300. So 105 divided by 300 multiple by 100. So then what is the percentage?
38%.
35 percentage, right? So here the diagonal is this way, but you are not thinking about that way, right? So just you can your mind fixed to that diagonal element, right? That not the meaning of that one. You don't check that theory behind that. So it means accuracy means what? Correctly predicted. So correctly predicted means actually the label is that one. Predicted label also the same one. That is a theory behind that, right? But you just know the diagonal element, just you can get the sum and put, then you lose the marks, right? That doesn't happen normally, right? So similarly, now if you want to calculate the precision, right? Precision of class 1. So here for class 1, that this is the predicted one, right? So 88 over correctly predicted one. So if you look at the same way, now correctly predicted one, this one, right? So now what will happen? You can consider this one. So if you consider that one, that is wrong, right? So here correctly predicted one, 38 divided by 88. Here precision for this one, 112 total. Sum of this one, 112. Correctly predicted 42, right? This one. If you look at the precision for class 3, altogether get the sum of this one, class 3, this one, 35, right? Similarly, if you consider the recall, for recall for class 1 means here, this one, you need to get the sum of these 300 over correctly predicted class 1, this one, 38. Here, 42, this one, 110. Here, 35, 110. So this is the way we can calculate, right? So be careful with the question, right? Maybe definitely you need to check actual predicted. Where is actual, where is predicted? Maybe I can swap where and where, here and here. Similarly, these labels also you need to consider, right? Don't think always I put the same order, right? So that's the way we can calculate the precision recall. Based on these two, you can calculate the F1 score as well, right? So these are all are about the confusion matrix, right? So if you have any questions.